parasite comes into your bloodstream and it replicates through its trypanomastoid form. The second stage, if it's developed enough, it will, through your bloodstream, it will go into your central nervous system and it will affect your behavior, it might make you confused, and it disturbs your sleep pattern, your sleep schedule, which is why it's commonly called the African sleeping sickness. And it's fatal if you don't treat it because it damages your central nervous system. It occurs in 36 sub-Saharan African countries exposed to the tsetse fly, which is the vector for Trypanosoma brucei. The recent epidemic in Africa from 1970 to 1990, that was the most recent epidemic of African sleeping sickness, but thankfully it's been cut down and controlled by WHO or World Health Organization. Um, Control efforts have actually done really well. They've lessened the number of cases by 73%, so that in 2015 there were only 2,804 cases reported. Trypanosoma, something interesting about this is that Trypanosoma brucei can alter its surface proteins so that white blood cells can't identify that it's a foreign cell that's escaping engulfment. So here we look at the global distribution of Trypanosoma brucei, or it's the same thing as a global distribution of the disease of African sleeping sickness. So it's pretty much found in 36 sub-Saharan African countries right here. Habitat and niches. So the Trypanosoma brucei, the parasite, uses two hosts, a tsetse fly, and it can use any mammalian host, including humans. It resides in the bloodstreams of both these hosts. So what happens in this cycle is that you start with a tsetse fly that has the parasite, and it bites a human. And then when it does this, the parasite will go from the fly into the bloodstream of the human. There, it will enter its trypanomastoid form, and it will reproduce. It will go through the bloodstream of the human, and it might affect stage 2. It might reach your central nervous system. Anyways, while all that is going on in your bloodstream, another fly can come bite you and then pick up the parasite for itself. Now, in that fly, Trypanosoma brucei will actually replicate in the midgut of the fly, and then it will reach the salivary gland of the fly, where it will be where that fly will again transfer the parasite to another host, another mammal or another human being. So it's a never-ending cycle of going between a host and a vector, but it can replicate in both of these. Food web. So Trypanosoma brucei is not your average food web. It doesn't look like your average food web because Trypanosoma brucei is not a predator, it's not prey, it's a parasite. Difference between a predator and a parasite. So predators take energy from other organisms, and parasites do as well, but the thing about parasites is that they can only take their resources from one host only. They only take it from one host. And I know that they can switch between tsetse fly and mammals, but at any given time, they will only take their resources from one host, whereas it's not the same for predators. So over here, of course, the two hosts that can host Trypanosoma brucei would be humans, other mammals, and the tsetse fly specifically. Next is a fossil. So it's kind of difficult to find fossils of Trypanosoma, but we found a fossil of an old tsetse fly that's been preserved from the Eocene epoch. This was found in, I believe, fossil beds in Colorado. This is a better fossil in that this is a fossil of a tsetse fly preserved in amber. It was found about 97 to 110 million years ago. And in this fossil, you can actually see, this is a zoomed up image. This is the proboscis of the fly, and this is the midgut of the fly. And in both of these, you can see that there is trypanomastoids in the salivary gland. This is where the fly is about to infect it. This is the proboscis of the fly that bites the human and infects the human with these parasites. And then this is the midgut where the trypanomastoids of Trypanosoma brucei will reproduce. and replicate. This is my bibliography. That is it.